Hello everyone, I'm Yanwei Huang from Zhejiang University. I'm glad to present our work, Table Illustrator, puzzle-based interactive ordering of plain tables. Before the talk, I want to thank my best collaborators from Zhejiang University and Newcastle University. People nowadays often use data tables in documents and reports. For instance, the tables here are selected from a financial report and a web page. As the purest form of data, such tables are straightforward enough to present data details and are widely used by data practitioners. We refer to such tabular data without visualizations beyond stylings as plain tables. However, to create plain tables can be challenging. In practice, data practitioners often need to carefully design table layouts and styles to improve readability. For instance, here are a few possible table designs based on the same input table, and note that these are only a few examples, and such a design space can be really large. Existing table ordering tools can fall short in helping users rapidly prototype plain tables. For instance, data analysis tools provide diverse data operations to transform tables into different shapes, but they lack sufficient support for adjusting table layouts and styles. By contrast, many users prefer to use spreadsheet tools such as Excel to create tables, mainly due to their flexibility of cell interactions. However, it still remains laborious and time-consuming for users to prototype complex tables with detailed designs and large data size. So these limitations drive us to develop a tool that balances flexibility and efficiency. And to this end, we have conducted 2 pilot studies to identify the challenges and requirements. In the first study, we interviewed 10 table designers and focused on 2 key themes. First, we asked them on their design workflow, including the steps and their preferences if they used multiple workflows. Second, we inquired their design process, such as the software and tools, their design considerations, obstacles, and specific requirements. The takeaways are as follows. First, we observed a diverse range of workflows, utilized tools, and design considerations. The main focus of their design was structural and stylistic changes to tables. Finally, we identified 3 challenges: the lack of clear guidance, the iterative nature of the task, and the presence of repetitive or trivial interactions. In the second study, we conducted a content survey to figure out the design patterns of real-world tables. Specifically, we surveyed more than 2,500 tables from the table bank dataset and iteratively summarized the design space of plain tables. The design space consists of 2 primary dimensions: structure and style. The structure part incorporates patterns regarding the spatial arrangement, and the style part shows factors affecting the visual appearance of tables. More details about the patterns can be found in our paper. So to wrap up, we have shown that existing tools can fall short in helping users rapidly prototype plain tables, and this fact can be worsened by the large design space. But what are the reasons, and how can we solve this? To answer the question, let's start from an interesting observation. Data in spreadsheets are often hierarchical, and this can leave semantically related cells separated in non-adjacent regions. Therefore, if a user wants to perform an operation, such as merging the cells with blank ones, they have to repeat this for each individual cell. And we believe the key to addressing this issue is designing new user interactions, so that users can work with the semantically related cells as a whole rather than treating them as separate cells. And this means breaking away from the traditional cell-based interactions and embracing a new interaction paradigm. To this end, we have proposed a novel table interaction paradigm where we represent tables with an intuitive visual metaphor, puzzles. Specifically, data entities in a raw dataset or other semantic cell groups can be visualized as puzzles. In Table Illustrator, users can combine puzzles through drag and drops to construct diverse tables in an efficient way. Now let's take a look at the interface. It consists of 3 views: a data view for importing and visualizing data, a canvas view for table instruction, and a configuration view for table elaboration. Now we go through the usage of the system to see how a user can use the system to make a sales report table. The user begins by importing the sales dataset into Table Illustrator. The dataset comprises 4 entities: continent, country, year, and sales, as listed in the Entity panel. To construct the table, the user can drag the continent entity onto the canvas, which generates a puzzle. Each cell within the puzzle contains a continent name with only the first two values initially displayed. To view all values, users can either click the Expand button on the puzzle or switch to the Preview mode to expand all puzzles simultaneously. The users can proceed by dragging the country entity to the bottom edge of the puzzle. Since there are multiple possible results, a selection window appears, displaying local previews as glyphs. The user can choose to insert the countries hierarchically. Next, the user prefers to build a crosstab showing the annual sales of different regions. They then drag the entity year to the canvas. They want the years to be arranged horizontally, so they click on the Rotate button to transpose it. Because the years should be placed top right of the puzzle, the user can drag it to either the top or right edge and select the crosstab option. Meanwhile, they also drag the entity cells to the body cells, filling them with sales values. Now the user wants to calculate the total sales for each region, so they continue to drag the sigma icon to the right of the years. After appending the total column, they drag the entity sales again into the column for total values. By checking the preview table, they find the table meets their goals, but is too plain to present to their leaders. They then adjust the table by configuring puzzle and global parameters. First, they click on a cell to be altered. By clicking on the cell Asia, all cells belonging to the same entity are highlighted, indicating the mutation scope. Meanwhile, the first tab of the configuration view has provided several structural and stylistic parameters for the selected puzzle. To add the indices, the user changes the key parameter, putting the indices on the left of the selected puzzle. Similarly, they set the key parameter for countries, position the indices on the left, changing the pattern to numerical, and nesting them accordingly. Next, the user wants to bold the total column. They then click on Total, switching to the second tab for global configurations. They find the scope current column and set the font weight to bold. Besides, in the panel of hierarchy, they set sequential background colors for the row header. Detail parameters are displayed by expanding the panel. The user chooses to change the color. They further color the column header in a similar way, leading to the final table. And eventually the user exports the table. They can further explore different table layouts or styles by trying different table configurations according to their preferences. Throughout the process, the user acquires a smooth and efficient experience in rapid table prototyping. To evaluate the system, we conducted two within-subject user studies comparing Table Illustrator with Excel. Each study involved 15 participants, and the pools for the two studies were different. The differences of the two studies were that we did not provide tutorials about Excel's advanced features, like pivot table, in the first study, so participants mainly used the basic cell editing features. But in the second study, they were provided such tutorials, and they tended to use the advanced features. All participants were asked to complete 4 tasks using two systems. Tasks 1 and 2 were meant to construct tables of student scores in different shapes and styles. Task 3 included the pivot table, and Task 4 involved the descent table for financial reports. In the first study, our system outperformed Excel in Tasks 1, 3, and 4, with users completing the tasks faster and using fewer mouse clicks. However, for Task 2, users spent more time and there was no significant difference in mouse clicks. This was due to the small size of the table and the need to understand the specific puzzle parameter. This makes direct editing in Excel more intuitive and efficient. In the second study, results were similar to Task 1, but there were some interesting differences. Users spent more time in Task 1 and 2 when using Excel, but less time in Task 3. The same pattern was observed for the number of mouse clicks. This may be because the table in Task 3 resembled a standard pivot table, saving time and interactions. Tables that deviated from the standard pivot table, like in Task 1 and 2, required more time and interactions. For more insights, please refer to our paper. We also measured users' workloads through post-study questionnaires in both studies. The results support our hypothesis that users perceived less burden when using Table Illustrator than Excel. Finally, we collected some qualitative feedback from participants. Most users appreciate the system's intuitiveness and usability, and other users appreciate the expressiveness of our table parameters and the efficiency in prototyping diverse tables. So to conclude, we have conducted 2 pilot studies to inform the design of a tool for rapid table prototyping. And we also introduced a new table interaction paradigm based on the metaphor of puzzles. Following this approach, we developed the tool Table Illustrator, and we also demonstrated the tool's usability and effectiveness during our 2 user studies. Thank you for watching this video, and please read our paper if you are interested in this work.